Hello, everybody. My name is João Pedro. You can call me John. I'll be presenting to you guys today Rails solution to job management using their very own native solid queue. So first things first, what is it? It's a database-backed active job queue. It was first introduced in Rails 7.1, and it's their own product. You don't have to add any external dependencies. If you're a Rails developer, you probably have some sort of contact with queue management systems, something like Sidekick or Resc. And it's designed for simplicity, and it has tight integration with Rails and Active Job, which it uses under the hood. And here are some reasons why use Solid Queue, right? First things first, it uses whatever database that your app uses. So if you use Postgres, MySQL, SQL Server, whatever, it's all right there in your own application. And with that, you don't actually need to use something like a separate container to run another instance to run your jobs. Sidekick requires Redis, and that needs to be run as a separate instance aside from your application. Its dependency is moderate. Why moderate? The way that it's set up, since it does use your own database, right, to run everything, you can run into issues with N+1 problems, right? So the way you set it up, if you make one or two loops more than is required, that can actually affect some of the performance, right? So as long as you code everything right and configure everything right, it's good to go straight out of the box. Its performance is built in. Sidekick has a few plugins that helps out with its performance. Its job uniqueness is strong, and Sidekick can have a strong job uniqueness, but it depends on the way that it is set up. And all of the databases that SolidQ run in transaction blocks. So if in case one of your jobs doesn't work out, if it fails, none of the workflow of your application is impacted at all. Its deployment is simple since it is built into the application itself. And it doesn't have any native web UI features yet. That can be coming soon, who knows? But it is really easy to set up. And during my demo, I will showcase a simple UI that helps us see a few things a little bit better. Okay, so SolidQ is actually composed of a few different key components. First one would be the dispatcher. It's responsible for moving jobs between different states, moving scheduled jobs to a ready state when their time comes, cleaning up completed jobs, and managing recurring jobs. And here is an example of a dispatcher. It already comes in built into SolidQ, but this is just to help you see it a little bit better. A worker. So jobs need workers, right? The job executes simple commands or complex commands, but a worker is the one that actually places that job in an active queue. So workers are responsible for executing the jobs from the queue. They claim jobs whenever they're in a ready queue. It executes them, handles successes and failures, and also manages retries. Another key component is the supervisor. This is optional, but for applications that are very robust and have a lot of business logic, every now and then it's nice to add a supervisor. Supervisor, like the name entails, is responsible for managing workers. So it manages and monitors the health of the SolidQ system. It starts off starting and stopping workers and dispatchers. So it's responsible for both workers and dispatchers. It monitors the process's health in case any problems come up. Supervisor then does something. It restarts failed processes as well and reports the system status back to the user. One sec, let me just drink a sip of water. Okay. And another key component is the actual active job adapter from Rails. It integrates solid queue with Rails active job framework. It translates active jobs to solid queue jobs. It handles job serialization and deserialization. It manages job options like queues, priorities, and everything else. And it also supports active job callbacks and features. Okay, so I mentioned that solid queue uses the database, right? So how exactly does it do that? It has multiple tables that are used to create a job life cycle. And this is one of the tables, solid queue jobs table. It's basically the core table that is used throughout the process of the life cycle. So it stores all pending jobs that are waiting to be executed. And this is the column that it contains. So it has an ID, which is the primary key, a queue name, responsible for the queue name, priority. This is optional, but it's pretty nice to have. Schedule that shows when the job should run, the job class, like which job is going to run. So if I run something like test job.ruby, it will put that class here. And the serialized job, which would be a YAML encoded job data. And created that and updated that, which would be the timestamps. And its purpose is to, whenever perform later is called, we create a row within our database containing all of these things here. And the jobs stay there until a worker claims them or creates an execution. Second table that it creates is the solid queue executions. And this tracks each attempt to execute a job and ensures that the same job isn't run by multiple workers. And here are the columns for it. Has the job ID, which is the foreign key to the solid queue jobs table. Started at, finished at, expired at, pretty self-explanatory. And the worker, typo, worker ID, which is the ID of the worker process, and the thread ID, which is the ID of the worker thread. So when a job is picked up, an execution record is created here. And if the execution finishes successfully, the job is then removed. And if not, the execution becomes an orphaned or failed job. And then that, if we fall into this condition here, the job is then sent here to the solid queue failed executions table. This table stores data about failed execution attempts. It uses retry jobs based on error and backoff strategy. Little typo there. And this is the column for it. As the job ID, which links to the original job that was executed. The error class, like which class actually caused the error itself. The error message. So if we have a job that has like custom error handling and like error messages, it actually picks up that error message itself. So this is really cool to have whenever you need to debug a job that is failing. It also has the attempt number. So depending on how you configure your solid queue process, it will run an X amount of number, X amount of tries, and here it showcases that. It also timestamps when it failed, exactly when. So if you have a job that runs at a scheduled time, and for some reason it fails, you'll find out exactly when it failed here. And the schedule that is when this table will retry that job next. Okay, Okay, so the next table is the solid queue dead executions table. It stores jobs that have permanently failed after all of the retries. It allows for manual inspection and re-enqueuing. So if we have some jobs that have retried multiple times, and if we go to the database and we actually figure out what went wrong, if we can manually fix it, we can then enqueue this table to retry those jobs again. And the columns here, pretty self-explanatory. It's the job class and serialized jobs, information about the original job. The error class and the error message, again, really helpful to figure out what went wrong. And the failed at and the temp number is just metadata. And it re-enqueues the jobs if necessary, or you can delete them. So that's optional. Next table is the solid queue blocked executions. It stores jobs that are temporarily blocked due to external conditions. This is often used when a dependency is not met. So if we have like a concurrency limit or a resource is missing, or we have some sort of conflicting lock, then we can use this table here. Won't get into it too much here just because of time. And now we have the solid queue claimed executions. This one is pretty important. It tracks jobs that have been claimed by a worker but haven't yet finished. So whenever something is running, if we have a job that's currently in execution, this is the table that holds that data. And ensures that distributed workers don't process the same job twice. So we won't have any problems with like duplicating jobs and data in the database itself. Part of the locking mechanism when multiple worker processes are involved. And it's pretty self-explanatory. It has a job ID, process ID, when it was claimed, when it expires. And now we have the solid queue processes table. It registers active users, active worker processes in the system. It's used for worker discovery, cleanup of orphan jobs, and monitoring health checks. And we also have solid queue pauses. If we have quite a few jobs executing at the same time, we can actually manually trigger a pause, right, for those specified workers and jobs. And then they are placed in the solid queue pauses table. So if we actually place them here, workers will skip these jobs from it. So whatever's in here, workers will basically ignore them temporarily until we remove them from this table. Okay, so this would be like the regular process of how we would use solid queue as an example. First, we would define a job, right? And it inherits from the application job since it does still use active job under the hood. And then the second step, when we call perform later or perform now, Rails actually serializes the job and solid queue stores it in the solid queue jobs table. So you can see that here, I called perform later, and then I inserted it into the solid queue jobs table. And then the job is pulled from the database, and a worker process is always consulting the database to see if jobs are ready to run now, ready to run later, or if they're still in the queue. You know, they're not being run now, but they're in process of being executed. And this interval can actually be configured quite easily. I'll showcase this in a bit. And solid queue uses advisory locks and row level locking to prevent race conditions and double processing, which is awesome that it does that natively for us. It's basically what I mentioned just now. Whenever it is locked, it is selected and update skip lock. This is basically added to the query so it can be locked. Job can be marked as in progress, so if it's in progress, it'll be locked as well. Okay, so after all that, the job is actually executed. The job runs in a worker, thread, or a process. If it's completed successfully, solid queue deletes that job from the table or moves it to a completed state if configured. Okay, so this is something that I didn't touch up on. Since we do use all of these tables and we don't want to accumulate data, every time that something is successfully executed based on how you configured it, that data is removed from the table. So you don't have uh, a lot of data like being stored up like without really having much use for it, unless you do have use for it, like the stop processes table and the failed job execution tables. Unless you actually need to go back and look at the data, it's not really necessary for you to store that data. So everything is always cleaned up after a successful execution, unless you go back or configure it in a way that you want to keep that data. Okay, so if it does fail, we would go into the job failure table and raises the exception. This is stuff that I've already touched up on. And in case the retried tables don't work out, we fall back into the dead job table, and then here we can decide if we want to manually retry it or not. And it's always optional, but really nice to monitor the life cycle itself or clean up. So this can be done manually, or you can create custom functions to always monitor this, like to populate some sort of dashboard, for example, which would be pretty cool. Okay, so now that I've talked like crazy, let's actually show this in action, right? So I have an application that uses solid queue here. Let me just get down here. Let's run it. So I created a little dashboard so we can see how things work. Nothing too crazy. I'm going to simulate a number of website visits to emulate, if we were to have like X amount of users access the website at once and execute an X amount of requests, right? So that's always pretty cool to have. So this is the server running, and I'm going to enqueue, let's say 20 requests here. Okay, so here we can see that each of those jobs have been inserted into the solid queue jobs table. And if we go to our database, we can see a few different ones here. There we go. Sorry, I needed a refresh. And there they are. They're all created. And if we let me just adjust this a bit. They're all scheduled. None of them are finished, right? So I actually have a little script to run all of these jobs that are here, and they are all going to use solid queue. Okay, so here I executed it. We had 29 pending jobs. Here we created the workers, and it already processed all of our jobs. So if we go back here, all of them are completed. Here are the job types that were run. And this is the average time that it took to process each job. They don't do much at the moment, so they're going really, really fast. But here we also cataloged like users that accessed a few routes throughout our application. All of this using solid queue. So let's take a look at the code just a bit. The Q YAML file is our bread and butter for configuration. So here we can configure the dispatchers, the polling interval, the batch size, and the concurrency maintenance interval. And for workers, we have a few queues, right? Critical, default, analytics, and notifications. Like, so each job that we have uses queue as. This comes from Rails itself. I remember if it's active job, I believe so. To set that into a specific queue, like a specific priority, right? So I have a few jobs. Each one has a different priority, and here is where we set those priorities. We also set the amount of threads, the amount of processes, and the polling interval. What else? And we have an initializer just to set up solid queue. And here I have a supervisor just to log some information in case we need it. But that's basically it. This is all done natively using Rails. I just used chart kick and group date for the view to create these little graphs here, but everything else was run just with us executing our database, which I'm using Postgres, and solid queue under the hood of the Rails application. And that's it from you guys. Hope you guys liked it. Hope you guys give it a chance, and maybe try to create a few projects yourselves, you know. Have a good one.